And then if you run it and you say git init, so I'm going to start a Git repository. Underneath the hood, actually in the .git folder in a couple different ways, it creates 2 additional trees. These are invisible trees that you yourself don't do any writing to. Git manages these trees for you. Okay? The first one is the index, and then the second one is called the head. So the head is just pointing to something. We'll get to that in a little bit, but when you first start a Git repository, head doesn't point to anything. It's just an empty nothing. So we'll get into that. So if you run a Git status on this now, after you've initted a repository, you see 3 red things: file 1, file 2, file 3. And you'll probably recognize this screen. So what does this stuff mean? So when you do a Git status, anything in red is the difference between the working directory and your index. Okay? You can think of the index as the tree that I'm going to commit when I commit. That's the version of the files that I'm going to commit when I commit. Okay? Anything that's in green is the diff between index and head, which is the latest commit that your repository is pointing towards. Okay? So that's how you can sort of mentalize this thing. A lot of people think of commits as just a diff, like it's just a delta between 2 sets of files. And under the hood, Git may store it that way in some ways, but realistically, it's every commit, every SHA in Git, every time you create a commit, you can think of it exactly as pointing to the version of that directory at that time. It's all of the files and all of the folders at that moment that you committed. So you can tell from this, we have those 3 red files because the difference between the working directory and index, those 3 files are not in the index, so that's the red files. There's no green files because, well, index and head are the same thing. There's nothing to compare, so there's nothing to show. Now, if I git add file 1, here's what actually happens. Git underneath the hood puts that file 1 into my index. Okay? So now when you git status, you see a green file 1, and file 2 and 3 are still red because file 2 and 3 don't exist in the index, but file 1 does. And file 1 does not exist at head. So that's green. Okay? So now let's create a commit. I git commit-m, I make a commit message. What actually happens there? Well, what happens is Git takes the tree from the index, writes it, gives it a SHA, and then points head at that thing. Your index is now still the same. Your index doesn't change. Your index is still a directory of files. And head now points at that version of that directory. Okay? It's just another copy of those files under the hood. So now let's git add file 2 and 3. Those file 2 and 3 get added to the index tree. So now when we commit that version of the index, here's what's happened. Here we write another SHA. We point head at that commit. And then this little dotted line is what's used. Have you seen or heard the terminology of a parent? Git commit has a parent. That's simply saying, this was the commit before me. That's the version before. It can get complicated. You can have multiple parents, which is where branching and all sorts of stuff happens. Don't even worry about that at this moment. The thing we're worried about is understanding that each commit is a tree. So now we can see that head, master, and working directory are all the same. So when you do a git status, it'll say, oh, there's nothing. Everything's fine. Everything's the way it goes. Okay? So you have these 3 versions of these trees. So let's make a modification. We're just going to echo something into file 1, so we change file 1. And so we have a new version of that file in our working directory. So you can imagine what a git status is going to be. It's going to be a red file 1 because, again, we've modified file 1, but that version is not in our index. So if we add that to the index, boom, now that file gets moved over to the index tree. You see it's green now because the difference between index and head is that new file. And we make that commit again. And now, boom. You can see it just follows this pattern of you take whatever is in index, it writes it, gives it a SHA, connects it over, points head at it, adds a parent to it, and that's how it works. That's how these ideas of these trees come into play. I'm not going to cover the way branching and stuff works. Git manages a lot of the diffing and the combining of trees for you. You really don't have to worry about that much. But now you can sort of, if we think of it in these three trees, if making a commit is moving things from the working directory to the index to head, reset is actually going the opposite direction. So how many people have done a reset before, like a git reset? You have any idea what it was actually doing besides hoping that it did the thing that you wanted it to? So there are three types of resets in Git, right? There's a soft, there's a mixed, and there's a hard. It's nearly impossible for me to remember what does what, except when I think about it in this sort of mental model of these three trees. And let me explain how resets actually work in relationship to these trees. Okay? So we're going to first talk about a soft reset. A soft reset, all of that does is it points head at a different commit. That's all. So if we, for instance, run this command, git reset -- soft head ~1. In this case, head ~1 means the parent of head. So we take the commit that's at head, and then we find the one before it. We just follow its parent down. Okay? So what this means is I want to point head, instead of the commit that it's at now, I want to point head at the previous commit. So if I do that, that's all it means. So now if I make a commit from index, it'll just go on to this commit again. Soft reset is actually what I use all the time when I mess up. When I make a commit and then I realize, dang it. Either I wrote a wrong commit message, or I added a file I shouldn't have, or I didn't add a file I should have. More often than not, what I actually do, because I mess up all the time, is I accidentally make a commit onto master when I forgot to create a feature branch for it. So git reset soft head ~1 is what you can think of as undo. And I actually make a global alias for this so that I remember it, so I don't have to remember the syntax for it. So you can actually type this line into your terminal, and then you can just say git undo, and you'll be back to where you were. The awesome part about git undo is if we go back to this example, you'll notice it doesn't mess with your index at all, right? The index doesn't change. Everything that you had worked on and staged into the index is still there. So all you need to do is maybe make another modification, add something to the index, and recommit, and you're set. You can actually undo, so you git reset soft, git checkout -b, create your branch, that will copy all the changes over to that branch, and you can hit up arrow a couple times, find that commit message, boom, hit it again, and now that commit that was on the old one is now on the new one. There's a couple other ways to do that. That's the way I do it. There was a question in the back.
Yeah, I was just wondering, in that reset, is head ~1 equivalent to just head caret?
So I know that tilde and caret are treated they mean slightly different things. I, off the top of my head, can't tell you explicitly what the difference is. I can look into it though.
Just adding a bunch of carets, but maybe.
Yeah, so you can do head ~1, head ~2, head ~8, and it'll just keep following parent back. Yeah, there's you can also like look at a log, and you can actually just do a SHA too. You can put a SHA there instead of head tilde. This just means if you know it was the last one, you don't have to look up the SHA. So again, git undo. The second type of reset is what's called a mixed reset. By the way, you can ask questions at any time. You don't need to wait to the end. So
regarding the soft reset,
yes.
When you do that, what happens to the commit that the head previously pointed to?
We will get to that. What's cool, and TLDR for right now, all of them are stored, at least for a good long period of time, like at least a month. So don't worry, like, we'll get to the stuff that's dangerous here in just a minute, but soft reset is always fixable because it only points head. Your index and working directory aren't touched. So a mixed reset is the equivalent of a soft reset, but it also modifies your index. So while I don't typically do a mixed reset pointing to an old commit, I'm going to do that right now just to show you in the similar sense of doing a soft reset what actually happens. So if I do git reset head =1, you'll notice I don't have a -- mixed, but that's because mixed is the default. You can do -- mixed if you want, but in this case, it's shorter. So if you just do a mixed reset to head =1, here's what happens. You do exactly the soft reset, but then it replaces your index with the contents of the tree from that commit. Okay? So it's just, instead of only affecting the right tree, you're affecting the right and the middle tree. That's a mixed reset. That's it. So I typically don't use a mixed reset to go back to a previous commit and modify the index. You totally could. What I use a mixed reset for most of the time is to just reset to the existing head. That is, in essence, is just unstaging stuff. It's removing stuff from my index and putting it to where it was before. So I use it like this. So I would, okay, in this case, I have a modified version of file 3 and a modified version of file 2 that I have made and staged. So I'd done git add file 1 and file 2. So those changes are in my index. And a lot of times I'll be like, oh shoot, I actually don't want to commit file 1 in this commit. I want to do that in a separate commit. Well, because you can think of this as a tree, a lot of times when I first started Git, I would do like git remove file 1. Well, that actually removes the file from the index. It actually deletes it, but from the index part. And you don't want to do that. What you want to do is a mixed reset on that particular file. And again, you just cover over the index. So then you can do a git add whatever back to the way it was. So you can also do a mixed reset to just an individual file if you want. So you can say, okay, take the file from head and put that version of the file into the index. So I actually use this, again, with my global alias, because I can't be bothered to remember the actual syntax for stuff. So I git alias unstage. So if I've added stuff to my index and I'm like, shoot, I don't actually want to commit any of that right now, I can just type git unstage, and it just wipes my index and makes it exactly what head is. Right? It doesn't touch my working directory. It doesn't change the files that I've edited or modified, but it allows me to re-add things to the index to change what I'm going to commit. Okay? And similarly, I can say git unstage file 1 if that's the only one I want to unstage. Right? So the last type of reset is what's called a hard reset. Okay? A hard reset modifies head. It sets the index to the contents of that tree. And it also sets the working directory to the contents of that tree. Okay? This is the only one that can actually cause data loss in Git. Okay? And how you do that, well, we can see in just a second. Using the same thing, if I hard reset to a previous commit, again, what happens is I move head, but then the contents of my working directory and my index are overwritten by the tree from that commit. Okay? Now, if I haven't saved somewhere else the contents of those files that I had changed in my working directory, those changes are gone. Okay? So use hard reset very cautiously, unless you've made a bunch of changes and you know you don't ever want to do that again. A lot of times, if I've tinkered with stuff and I know that I don't want it, I'm very tempted oftentimes to just do this, git reset hard head, and that means like, okay, I made a bunch of changes in my working directory and I don't like any of them. So just wipe my index on my working directory, set it back to the previous commit, right? And again, what that looks like is this. If you reset head, it just takes the tree that's from the current commit, wipes it back across. I don't actually recommend doing that because more often than not, I'll tinker with stuff and I'll think I don't want it anymore. And then I'll code stuff a little further, and I'll be like, actually, I kind of did want that one thing I wrote. I did a thing that kind of halfway worked, but I kind of want it back. If you just do a hard reset over it, nope, it's gone. So how can you actually save your working directory? Well, there's a couple ways. My favorite way is with a git stash. Has anyone used stash? They use stash all the time? Okay, cool. Well, it's really easy to understand what stash does, again, in this mental model. So let's say I'm given this state. So I have a working directory. I've modified file 1 and file 2. By the way, the colors on this are just to show you that they're different versions. They don't actually mean anything, the green or the orange. Don't worry about it. But you can see by this that I've changed and I modified in my working directory version file 1 and file 2. Okay. Well, let's say that some emergency ticket comes in and I have to make a quick bug fix, but I'm in the middle of this thing. I don't want to get rid of that stuff, and I'm not really ready to make a commit yet because nothing is quite working, and I don't want to create a branch yet because I'm not sure if I'm going to keep this or what's going to be, but I want to keep the state in my working directory. Okay. So what I do is I run git stash -u. The -u flag, by the way, stashes all my untracked files. So the files that I've created that are new. So when I git stash -u, it'll actually take all those created files, throw them into the stash, and leave my working directory totally clean. So here's what happens when I stash -u. Also, similarly, if you want to describe to yourself what this stash is and make a memo, you can totally do that with git stash save -u and then a description in quotes. Git will attempt to create a good message for you. It'll tell you what branch it was on and the files that were modified. So sometimes that's enough, but a lot of times I want to be a little bit more descriptive so that I can look back and know what's going on. So a git stash simply makes a copy of my working directory and then does a hard reset. That's what a git stash is. Okay? Simple. Now I have this back over here. So then I make my emergency fix. I change my version of file 3. So file 3 is new in my working directory. You can see. I add that to my index. So now file 3 is modified in my index. I make my commit to do my emergency bug fix. That creates a new SHA with that version of the tree. And I still have my working directory, the old version, sitting here in my stash. I can look at that list. So I can say git stash list. And it will actually print out all the stashes that I have. So you can stash multiple things, and it will just add it to a list. It's like an array. Just keeps adding more and more stashes. So there's a couple ways. The other thing you can do is git stash show. So if you want to investigate one of them and see like, okay, well, the file 1 had a modification, and I actually added one line to file 2. So you can get an idea of what's going on there. If you do a stash list, there's that stash at 0, stash at 1, stash at 2 that'll be listed on the side. You can actually specifically put in one of them that's in that list, and it will show you the contents of that thing. So how do you actually get a stash back? Well, one way to do it is with pop. People use pop, git stash pop. So what git stash pop does is this. So it will attempt, Git will, you'll notice file 3 is modified in the working directory, but file 1 and 2 are modified in the stash. Well, Git will do its best to merge those two trees together. So as long as it can do so with no merge conflicts, and it will actually, if there are merge conflicts in that, it will just simply apply those merge conflicts to those files and say, you fix it. Which is great because you're not in the middle of a merge, you're not in the middle of a commit, you just fix the files, right? It's fine, it's totally great. But when you pop, your stash is gone. So the original changes are gone in the stash. Those things have disappeared. There are some ways to get them back if it's like an emergency, but I prefer, they're risky. So I prefer not to pop. You can actually do git stash apply. After this, you can specify the stash too in the similar format of stash at curly braces 0, 1, 2, 3 if you want. But git stash apply, what it does is the same thing, but it doesn't delete my stash. It leaves it there. So if I make some modifications or like it tries to merge something and it ends up screwing everything up, I can hard reset again, change some things, and get my stash back the way it was before. So I can save that around in case I want to. I like keeping the data around. I feel a little bit safer that way. But it lets you really sort of pause work in progress and then move to something else and go back to where you were without having to create a commit or checkout or anything else. It's really kind of nice. You can also, let's say I have a stash, and I'm like, okay, I want to pick back up where that was, and I know that I just want to create a feature branch from that. You can actually git stash branch, type in your new branch name, and then specify a stash optionally. You don't have to have that stash at 0. It will default to stash 0. But I put it on there just so you know that you can specify it. And this will actually create a new branch, apply the stash to the working directory, and you're like plopped right into like, ooh, I'm right in the middle of my feature branch now. It's kind of nice. It lets me really not worry about the progress of like, oh, am I ready to commit this thing? All right, I'm going to make a commit where things are broken and then like undo it later. That's just gross. So I don't even have to worry about it. Stash is awesome that way. Now,
does that pop or apply the stash?
I believe this pops the stash. But you're in a feature branch now, so the assumption is that you're going to make a commit soon anyway. So now to the question of what happens to that commit when you do a soft, mixed, or hard reset, when you change head. Anyone heard of the RefLog? Anyone use it? The RefLog is awesome. RefLog is a meta repository for your repository. Really great. So let's get back to this scenario again. We have these 3 commits. I've made 3 commits on my master branch. And then I'm like, crap. And I reset one of them. Maybe I did a hard reset because I thought that something was messed up. And then I'm like, shoot, I needed the thing that was in that commit. Crap. Well, because when I git log, it's gone. It's not there anymore. Git log, by the way, in case you wanted to follow along, when you git log, it points at head, and then it just follows that parent tree all the way down. That's what a git log is. It just says, okay, here's the commit that head points at. What are its parents? Okay, print that one out. Its parents, print those out. Parent, and just keeps following down. Kind of nice. Well, now I git log, and that thing is gone. I can run git reflog, and you can see everything, every change that has ever been made to a head gets logged in this big list of stuff. It's every change that I've ever done to this repository. So you can see my initial commit here, my adding files, my modifying file 1, and then my reset to head. Okay? So the awesome thing here is I have this shortcut, head at 1, if I really want to. There's also a SHA. So I can copy that SHA, and I can say git reset hard, that SHA. And boom, my commit is back. Got everything I need, and it's just as if I was in that state, at that tree, at that moment in time that I did that commit. Again, this is the awesome thing about thinking of commits as trees, as groups of files and folders, is if all I have to do is reset to that thing, and there I am. I've got everything the way I was before, and I just follow that parent tree all the way down. I've still got all my history. Okay? I can even use that SHA to be like, okay, I don't want that commit in master right now, but I want to use that commit in a new branch. I can check out -b new branch name with that SHA, or like head at 1, and that will just, like create a new branch and reset head to that commit. And then I can maybe create a pull request or do a merge later on. It's really awesome. The reflog is great for finding stuff that you did and stuff that got lost. Like, have you ever accidentally deleted a branch? And then you're like, where are all those commits? Where are all those changes? You can look in your reflog. They're all there. It's really hard to lose data in Git when you've made a commit. If you've made a commit, that stuff is there somewhere. You just got to find it. So being able to search the reflog is actually really interesting and important for emergency cases like this. So you can git reflog show a branch name, and it will show all the changes to that branch name. You can even go so far as to specify a date range. So you can say git reflog show master at 1 week ago, and it will show all of the reflog entries from last week. I can think of a number of times where I was like, I created a branch and deleted it, and I know that there was a thing in there, and I know I did it like last Friday, but I don't remember what the commit message was. I know there was a thing. So I can do this, look through the RefLog and be like, there it is, got it. And then I can just reset to that point in a new branch, and I'm back to where it was. Everything is golden. It's wonderful. All right, any questions on the RefLog? How am I doing for time? We're doing great. All right, another thing. The interactive rebase. People heard of this? Anyone done it? Sort of magical, a little terrifying, but I use this for very specific things. This happens to me a lot. I'm not the most organized developer, okay? I start off really organized, and so I'll say, okay, I'll start making some commits. So let's take a look at my Git log as stuff happens. I say, all right, I make a commit that fixes a display bug, and it fixes issue number 145. Done. Awesome. I have created this branch. I'm going to fix a couple bugs and make a pull request. Great. So boom, I fixed my first bug. On to the next one. So update my comparison text. Like, okay, I got that done. And then I'm going to check the next thing, and I realize, oh, I actually fixed the display bug this time in this commit. Got it. No, wait, nope, that didn't fix it either. Okay, but I got it fixed, and now my third bug that I'm going to fix, better markup for the container. And then like, still the display bug is still broken. Some swearing. And then like, okay, I'm just dumb, and that's why I didn't fix it in the first place. So my list of branch commits will look like this, because I'm not terribly organized, and I don't bother really checking things thoroughly as I'm doing them. So there's a couple options. Here's the really important part about this, everything that we're going to talk about in interactive rebase. I very much encourage you not only do this before you have pushed to your server, and we'll get into why afterwards, but it will create a huge headache for you if you don't. It involves things like force pushing, which is really gross. Don't ever do that. I'll get to that later. Force pushing is rude, so fix all this stuff before you push. Don't be like really aggressive about pushing your work to the server. Like, get it done. So here's what you can do. I have that list of commits that I've done, and I'm like, ugh, that looks terrible. It makes me look really dumb. So I can just git rebase-i head ~8. There were 8 commits in that list. Okay, so head ~8. Git will then open in my editor, whatever editor I use for like my commit messages or whatever your editor you have your terminal set up to, with a file that looks something like this. Okay, it shows me those 8 commits in reverse order of when they happened. So starting with the oldest all the way down to the newest commit. And then it gives me some options and some commands that I can do. Pick is basically just do this commit. It's fine. Like, don't worry about it. Just move on. Just apply that commit just like I did it in the first place. Okay. Reword will open the editor to the commit message of that commit to let me change it. So if I want to modify that commit message, I can change it through an interactive rebase. Edit will begin to apply that commit, apply the working directory, the index, but before it actually makes the commit, it'll just dump me into terminal to let me like add one more file or make some change, one little tweak, and then I can make my commit. And as soon as I've committed, it'll continue with the rebase. Okay? I don't do that a ton, but you totally can. It's actually really powerful. Squash will simply take the commit before it and combine the 2 commits into one. Okay? It'll actually combine the commit messages. It'll do some stuff for you. I actually don't use that one very often. I use fixup most of the time for that. Fixup will do the same thing. It will do Git will do its best to combine all the diffs for those trees, and then just use the commit message from the first commit. Okay, and then exec, you can actually insert a line into here and run a command in the command line in between some commits if you really wanted to, if you need to clear something or for whatever reason you needed to do that. I've never had to, but you totally can. So let's actually think of how I would go about doing an interactive rebase for this to make me look better. than I am. So I look at my first line. Okay, fix display bug. It fixes. I got my bug number in there. Awesome. That's fine. I just want to pick that one. So on to the next thing. Update comparison text. I didn't include my bug number in there. I forgot. So I actually want to I want to reword that commit. Okay. All right. This next thing actually fix my display bug. So that one I'm like, that's a terrible commit message, and that's it's part of the first thing. So I'm just going to reorder those lines and change it to F for fix up. So it's going to combine those two commits into one thing and just use the first commit message. Okay. So let's look at the next thing. I hate display bugs. We do the same thing. I simply put it after the next thing again, change the first thing to F for to fix it up with the commit at top. This is just in a text editor, by the way, so you can type like normal. You can just move these lines up and down. There's nothing special about what's going on here. Look at the next thing. Better markup for container. Okay, that was a good fix. I needed it, but I still didn't have my bug number in there, so I'm going to reword that one too. And then these last three are the actual fixes, hopefully, to this thing. So I'm going to do that again. I'm just going to move all those three in line and say fix up. As soon as I close this editor window, Git begins to churn through my stuff. It goes through that first commit and then squashes those trees for those first 7 or 6 things all together and uses the commit message for the first one. Then it opens my editor and I can say, okay, that fixes number 174, and now that one fixes 166. And then magically, when I git log, my branch looks like this. Hey, I look super organized. I'm going to look so much better to my friends. The reason I really like doing this is because, to me, a Git repository is it's not just about keeping track of all the code as it changes. It's about communicating what those changes are to other people. So this allows me to, once I've made a bunch of changes and I'm satisfied with those changes that I've made, it allows me to sort of think about them as a whole and change the way I describe them so they make sense together as a group. Okay? It also lets me not have to worry about like doing everything perfectly right when it happens, and lets me fix everything later. Yes?
Does the RefLog still contain the original?
Yes, it does.
So
Absolutely.
there's evidence that this
If you really want to search for my failures, yes, they will be in the RefLog.
if you've ever used Git with a regulated
Yes. Well, and here's one interesting thing to note about that. One of the reasons that they're still in the RefLog is if we compare these 3 SHAs to the SHAs of the original commits that I made, all of those are different. These are new commits. These are new things that exist in the RefLog, okay? Which is why we can't just push them to the server, again, if I've already pushed those previous things. Because the server is going to say, now you have like other commits that are supposed to be pointing to this parent, but now you're saying this one, no, I don't know what's going on. You got to fix that. Or you have to force push this branch, which means get rid of everything else. Is anyone familiar with force pushing? Don't do it. A lot of people like to do it. I hate it. It's like lying. The reason why it's actually really bad, especially when you're collaborating with people, is it's totally plausible. All it means when I force push is to take this branch that I'm working on and basically delete the branch. It basically does a soft reset on the server to my new commit. That's what it does. Okay? The reason that's really bad is if somebody else has pulled those previous changes, they make some changes. They try and push, and the server's going to be like, I don't know what you're talking about. I don't know that SHA. What do you know? I can't. So now you're making the headache for them because they've got to like, oh great, well now I've got this commit, so I've got to like stash that over. I got to put this stuff all in a different branch. I got to pull down your changes, and I've got to try and merge the two together that I didn't even know what you're trying to do in the first place. It's terrible. Don't do it. The only reason ever to force push in my mind is if you accidentally check in credentials or like log usernames and passwords into your repo, you can force push and then garbage collect on the server and clear the RefLog, and those things are actually gone. But don't check in credentials and you don't have to worry about it. Yes?
I've sometimes forced pushed if I have a personal fork of the repo, and I'm the only
Certainly, if you're the only person who is working on that thing and you know that no one else has done anything with it, you can totally force push relatively safely. It gets really junky. It's a bad habit to get into, with the idea that I can just always, like, it's like, to me, force pushing is like sweeping the dust under the couch. Like, it's just like, like just, I don't know. I don't like it. I know there's a ton of people who love doing it, and there's workflows in enterprise customers who use force pushing all the time. I just don't like it. I think it's gross. If it works for you, then great. Yeah.
So when you push what you've done here,
Mm-hmm.
is that the only thing that's going to the server, or is everything in your RefLog going there as well?
That is true. Yep. Okay. So we've talked about doing an interactive rebase. Yes.
Sorry, can you clarify that? It's my understanding it's just everything, if you haven't pushed, if stuff in your RefLog has not been pushed, then that stays local.
Yes.
And you're pushing it.
Correct. It pushes up the RefLog for things that are getting thrown to the server.
But like your squash commits, the commits in place with the squash are still local to your RefLog, but aren't pushed up if you haven't already pushed them.
I'm second guessing myself now. So that's because I'm on video. I'll say we should look it up later. Yes, we'll verify that, and I'll let you know. Okay. Yes.
During the interactive rebase, while Git is doing the
Mhm.
piecing and the squashing and whatnot, is there opportunities for merge conflicts in there?
There's always opportunities for merge conflicts. Yes. Yeah.
So it would then just prompt you to resolve
Mhm.
those?
Yep. Sometimes it would, for instance, abort. It will just say, I can't do this. But yeah, it's important to know that, like, when you are squashing things together, you got to have a pretty good idea that, like, these things are all roughly doing the same thing. Similarly, like, you can totally reorder just all your commits. If you wanted to say, like, just do an interactive rebase and just shuffle them all around, that's fine. Git will just do everything in the order you tell it to do on an interactive rebase. But again, all those things are going to be different SHAs then. So, all right, last thing to cover. Blame. I love this. It lets me know who to be angry at. Most of the time it's me. I'll be looking through some code and I'll be like, who wrote this gross thing? I don't even know what's going on here. This is a terribly confusing line. There's no documentation. What is going on? I don't get why this line is even here. I don't know what it's doing. Why was this introduced in the first place? Again, I've done this several times, and it was actually me who wrote it in the first place. But let's say, okay, I got this line. I'm going to pick on this line. I don't know why I picked on this line. It's just an example. So that file that I was looking at is at libindex.js. So I can git blame that file, the path to that file. Well, Git presents me with something like this in my terminal window, which it looks a little gross. But if you zoom in a little bit here so you can see it, you'll notice, okay, what this is it's every line of my file. And on the left is the SHA that changed it the last time, along with the author and the date. So here's, yeah, super awesome, right? The first time someone ever showed me this, I was like, that's the most amazing thing I've ever seen. So you can totally get this. So now you have this SHA. You have the SHA of this thing, A8FD, whatever. And then you can actually look it up. You can git show that SHA, and it will like dump you into the diff or the commit that introduced that change. And you can kind of dig through it. All this is a little bit cumbersome in the terminal. So for all of you who may be using GitHub, any file you look at in the tree, you have this awesome button of this blame button. And if you click it, you get the file. And now you can find that line that you're talking about here. And you have the commit, the author. And you can click on that and get a nice pretty version of the diff with the commit message and see it nicely. We take this one step further, because if you notice, I don't know, a ton of people don't know about this, but that's the pull request that introduced this commit to the repository. So you can click on that PR and actually read all of the discussion and changes that came in with this pull request that explains why that piece of code is the way it is. It's a huge way to spelunk changes that you're working on where you're like, I don't think this is right. I don't think it's the way it should be, but I'm not really sure. So I'm actually going to find out why it was done in the first place. I know who to ask. I know who was thinking what at the time. I know the other changes that came in with it. It's just a great way to orient yourself around a specific change that was made to your repository, and you can totally spelunk all this data out of Git. It's really, really awesome. So just recycling everything once again. We've talked about trees and how they're snapshots of directories in time. Your working directory is the one that you're modifying. Git handles the index and the head. Reset allows you to move the head, change your index, and change your working directory in the reverse direction. Stash lets you save work in progress for later to move it into either back into your working directory or into a branch. A RefLog lets you look through your history and the changes that you've made. If somehow a SHA or a commit that you made is unreachable, you can look back and find all that stuff that was made. Interactive Rebase lets you see more organized than you actually are. And Blame will help you find out who did a change and hopefully why that change was made. Any other questions? No? Awesome.
Why didn't you give this presentation earlier?
Fair enough. Mostly because I learn more about Git every day. So it really, diving into some of the internals is really interesting to learn how this stuff works. And it lets you, and the reason I titled this talk, the subtitle of this talk was like being a more skillful collaborator, because this stuff allows you to like more properly describe changes and understand what you're doing so that you can more appropriately format your changes to communicate those changes to people you work with. And that's what being a good collaborator is about. It's not just about writing good code, it's about communicating why those changes are made and discussing them. So getting them to be more organized, getting to know why things happen, knowing how to like move code around and move the changes around to make it easier for you to present things in a better format.